Hi, I'm Michael Valeri, and welcome to the Valeri Analytics channel. This is our first lesson in the SQL 4-week immersive class. Thanks for joining us. Really appreciate you being here. We're going to talk about the what, why, and how of SQL, or structured query language. Before we get started, we have a jar of peanut butter here. Often we just put this on bread and we don't really think about where it comes from. But we all know that it comes from raw ingredients, peanuts. And these peanuts go through the peanut factory to create peanut butter. On the right, we have Michelangelos David. Michelangelos David was created from a block of marble, but we often don't think about the block of marble. That block of marble went through the chisel factory in order for Michelangelos David to be created. On the far right-hand side, we have a list of customers who shopped at Target who are pregnant. On the far left, we have an image of a data table, or the data of customers who shopped at Target and their purchase history. In 2012, a dad wrote a letter to Target, an angry father, after his daughter got pregnancy coupons in the mail. Pregnancy coupons, diaper coupons, baby product coupons. Dad was furious. He asked the Target, hey, why did my daughter receive this? And Target said, well, it's because your daughter's pregnant. So how was Target able to turn a block of data, customers' purchase history, into the ability to create a list of customers who are pregnant? This is the SQL factory, which is what we're going to be learning about in this YouTube series. What is SQL? How does it work? What does it do? And how do we write it? By the end of this lesson, you're going to know what SQL is, where it fits in analytics, why you should learn it, how does it actually convert a large table of data into something actionable, what are tables, data types, schemas, and then we're going to get started on the free YouTube 4-week series. The way this class works is there's going to be 7 videos, and each video will be about an hour to an hour and a half long that will cover a specific SQL topic. After each class, there will be homework that you can do, and I have answers supplied in the links below, as well as the homework. You can access all of this information via the Google Drive link below. And then at the very end of the course, you can fill out a SQL skills assessment where you'll be able to get graded by me. And if you want to book a meeting with me and review your answers, there is a Calendly link below in which you can book a review session with me of the entire SQL class for 90 minutes. So who am I? I'm Michael Valeri. I've been teaching analytics since 2017, and my career started teaching folks analytics when I worked at Amazon. I used to train interns how to write SQL, and I remember my boss taught me SQL on the whiteboard at Amazon using just markers. And that's when it clicked to me that this language, I studied accounting in school. I didn't study databases or database languages, and I was able to pick it up relatively quickly. And I believe that everyone can do that. So I've spent the last couple of years training program managers, product managers, aspiring analysts how to write SQL and how to use it in their daily job. And I've done this both in person and remotely. And now I'm launching this series because I want to be able to share this with the rest of the world. And I'm really happy you're here to learn this content. I think it's going to be really fun. So what is SQL? At its core, SQL is just sending a question to a database and popping out a table to get an answer. So we set a set of instructions to a database and out pops a table of data. What does SQL stand for? It stands for Structured Query Language, and you're going to see this acronym a lot, but what does that even mean? Structured Query Language, SQL. Well, a synonym, for structured is construct. A synonym for query is question, and a synonym for language is, I couldn't think of one, it's just language. So if we look at this other translation, construct a question, language, construct. Think back to the SQL factory that I mentioned a couple slides ago. We're using raw data to put through a factory to construct something, an answer. So this language constructs an answer for us through data as the raw input. And then the output is answering the question. So it's constructing a question language is another way that you can think about it. How do you pronounce SQL? I grew up in South Dakota. I spent many years there. And every South Dakotan knows that the capital of South Dakota is called, well, Pierre. South Dakotans know it's called Pierre, but everyone else calls it Pierre, non-South Dakotans. SQL has a very similar story. If you're an analyst and you use SQL in your day-to-day life, and it is part of your workday, you're calling it SQL, not SQL. So if you're a South Dakotan, you call it Pierre. If you're an analyst and you're writing SQL, you're going to call it SQL. So from this point onward, we're going to refer to SQL as SQL. And by the way, Fast and the Furious has 13 films, if anyone's curious. Why do we have to use this language? When I was first introduced to SQL, or SQL, I was like, we're already working with Excel. Why do I have to learn this database language? Why can't we just manipulate the data in Excel? Because doesn't that what Excel does? Allows us to take a large table of data and convert into something meaningful for us to look at. Well, that is true. Excel has a limit, has a 1 million row limit. And I asked my boss, well, hey, why not use Excel? And she said, well, how many rows of data do you think Amazon generates in a day? I said, I don't know, maybe 1 million a day? And she said, try 1 billion an hour. You can't possibly store that in Excel, which is why we use relational databases instead, because you can store a virtually unlimited amount of data. And this is the norm in the technology space. So where does SQL fit in the data flow? I like to think of using SQL as a means to an end. Folks just don't write SQL, right? Much like you won't just write numbers or words on a piece of paper. You do it with an intent. Trying to write a paper, you're trying to solve a math problem. So there's 4 steps in analytics, and SQL is the second step. Step 1 is identifying the problem. Let's think back to the original slide that I showed you about the ability to make a list of people who are pregnant based on their purchase history at Target. That's the problem that some marketing executives were probably sitting around a table at Target and said, we want to be able to send coupons to folks who are pregnant, so we better get their purchase history. And how are we going to do that? Well, that's where SQL comes in, the extract data phase. That's where we go down into the mine, we go into the database, and we uproot all of that data. We get a list of folks who, their purchase history, if they purchase diapers, cotton swabs, baby wipes, baby formula, etc. After we unearth that, we'll generally throw that into an analysis tool, a refinement tool. Tableau, Power BI, Excel. I like to think of Tableau and Power BI as the Pepsi and Coke of the analysis section of the analytics flow. Those are the most common tools that you're going to see. Tableau and Power BI allow you to create charts, graphs, in some cases actually write SQL in the back end to analyze your data. And that's a whole nother discipline, is actually building dashboards and analyzing it within these tools. And then the final step is step 4, is just answering the question that you originally asked in the beginning, step 1. Steps 1 and 4 require communication skills. So if you're a history major, if you're an art major, if you're a comm major, if you're someone who studied philosophy, you're probably really good at communicating your ideas, telling stories. This is all about telling stories, analytics, and SQL is just a part of it. So steps 2 and 3 are the technical bit of analytics, which I feel like gets maybe too much focus because it's really about communicating a story with data to somebody. Now, where do you think the bottleneck is here in analytics? Which step do you think is the hardest within an organization? Well, based on my experience, it's step 2. It's the SQL part. There's a lot of folks who can analyze data, ask questions, answer questions, but when it comes to actually going down into the mine and getting the data out, there's generally a very small analytics team and a group of folks who can do that, and they get a list of tickets, and it's hard to keep up with the demand. So much like a bar, wouldn't it be nice if you were standing in line and wanted a drink and you just wanted to jump over the counter and make your own drink without having to wait for an analytics team or the bartender to make you a drink? And that's the power of learning this language, is that you can bypass this bottleneck of the few people who can only write SQL, and then you can pull your own data yourself. You can go down into the mine and do it. And this is why I'm so passionate about this language, is because it empowers you and it will accelerate your career. The platform we're going to be using to learn SQL and actually analyze some data is Mode. Generally, the SQL bit and the analysis bit are separated into unique products. What's really great about Mode, the platform we're going to be using, is that the extract data and the analysis phase of data is embedded in the same tool. You don't have to leave the kitchen to roll dough and then go stick it in the oven in another room. You can all do it in the same room. And this is why Mode is the preferred product of analysts, which is why I love it and why we're going to be using it to learn SQL. Because it requires just a web UI, and we're just going to log in and make an account, and everything will be laid out for you very nicely when you're going through this series. So what are you going to gain from learning SQL? You're going to be able to talk to analysts in their own language, right? You're going to be able to go up to the bartender and articulate your needs and wants. And then in some cases, you're going to be able to jump over the bar counter and make your own drink. And you know, a bartender always appreciates when you know exactly what you want to order and they don't have to guess for you. So part 1, tables, data types, and schemas. I thought we'd start out here with just doing a review of what a table is. What is a table of data? And a couple months ago, no, I'm going to say actually a couple years ago, I had a bunch of compact discs in my closet, and I decided to put them into a table where I would list the artist name, the album, the release date, genre, plays, estimated times I played it, etc., rating, the price I paid for it, the value it's worth today, whether it was burned or not, and then playable. Is it disc playable, or did it melt on my dashboard? So on the left-hand side of this table, we call these records rows. So each CD gets its own row or record, or each album or each record is its own record or row. So every row is an album. On the top, we have the columns. The columns are the characteristics of these records. What row ID it is, that's a unique identifier. We call that the primary key in a lot of cases. The artist, the album, the release date, the genre, the plays. So the combination of rows and columns is a table, and that's how data is stored in a relational database. So the whole idea of SQL is that we're just going to manipulate a table like this using commands to extract the information that we want or need. Now, before we actually learn SQL, we need to learn what data types are and the schema. So the schema is the blueprint. It's the map of the table. It's what columns are featured in that table and what their data types are. So I thought what we could do is actually just run through each column and pick a selection below, whether that column is a text column, a numeric, an integer, a date, a Boolean, or a money column data type. So the first one is an integer. It's an integer because it's a number with no decimals and it is a whole number, making it an integer. The artist column is a text column, meaning that it can have letters and numbers. Artists sometimes have numbers as their name, like 50 Cent, for example, or 311. That's a text. Album is also a text, could have letters or numbers. Release date is a date. Genre is also a text. It could have letters or numbers. Maybe a genre is defined by a number. It could be possible, but I guess not in this data set. Plays, that's an integer. It's a whole number. Rating, that's numeric. Numeric means a number that has decimals, the ability to have decimals in it. Ordered price is a money column. It's numeric with a currency symbol. This is a data type within PostgreSQL, which we'll talk about more later. Market value, that's numeric. It's a number with decimals. Burned is Boolean. You'll notice burned, it's 1 or 0, or null in some cases. So Boolean means true or false, 1 or 0, binary. You also notice in some cases that a record might not have a 1 or a 0, it's just blank. Blank means null or the absence of data, meaning that we didn't actually know what the record should be recorded as. So it's a mystery. And we're going to get way more in depth with nulls as we go on in this course. Playable is also a Boolean column. So what does each row represent in this data set? It's an album or a record. So each record is a record. That's the granularity of the table. The level of detail of the table is that every row is an album or record. You could imagine you could design a table where every row was the artist. Which column is never going to have duplicate data in it? Well, we know artists sometimes have the same name, and sometimes artists release albums with the same name. For example, you could have Red Hot Chili Peppers release an album called Greatest Hits, and then you could have the Rolling Stones release an album called Greatest Hits. So we know the album name is not going to be unique. We know that albums can be released on the same day. That's not going to be unique. We know the genre is not unique. The rating, the price, market value, burned, playable, etc. Those things are not unique. You can have albums that share all of those characteristics in common. The unique identifier for an album here, the one that will never have duplicates, that is unique to the row, is called row, the column called row. It is the primary key of this table. So let's do a little quiz on data types. What I'm going to do is I'm going to show you a piece of data, and you're going to have to guess, is it a Boolean, a text, an integer, or a date? All right, let's start with the first one. False. Is that a Boolean, a text, an integer, or a date? This is a text column. This is actually the name of a metal band in Minneapolis. You think it would be Boolean? Let's try another one. 311. Is that a Boolean, a text, an integer, or a date? In this case, it's an integer, but it's also the name of a band. These seem like trick questions and a little unfair, and I'll get to that in a bit. Let's try one more. 4/29/1992. April 29th, 1992. That is a date. It's also the name of a Sublime song. What's the takeaway here? Well, the appearance of a piece of data can be deceiving. What you don't want to do is guess a data type. Instead, you want to look at the table schema first. So the schema is going to be your guide. We'll never want to guess data types just based on the raw data in front of us. We'll want to consult the schema, and this is really important because it's going to influence the way that we write our SQL throughout this course. So the schema is very important. The basic syntax of SQL. So we talked about, well, how does just this raw block of data get converted into a list of people who are most likely pregnant based on their target purchase history? Well, this data is chiseled down into something more manageable. using the SQL factory. And there is different keywords that are part of the SQL factory that do something different to the data. One keyword might select the columns in the data set. One keyword might filter the data in the data set. Another keyword might order it. You can think of each keyword as like arms in a factory. And each arm has a specific role or job in that factory, much like in a peanut factory, right? One piece of technology might deshell the peanut, and then another piece of technology might wash it, and the other one might smash it. SQL operates in a very similar manner with its keywords. So there's 7 keywords: select from, where, group by, having, order by, and limit. And we're going to go through what each of these keywords do to a very small table of data in a slide or two. And I came up with this idea when I was at a dinner party a couple years ago, and someone asked me, "Hey, Michael, what do you do for a living? What's your job?" I said, "Well, I write SQL and I teach people SQL." And they said, "Okay, well, how does that work?" And I said, "I could probably tell you with all the items on the table here how SQL works." And on this table, we had a glass of red wine, a cheese tray, a glass of water, and a knife. We had 4 items. And what I did was I used the items on the table and I taught folks how to use the keywords in SQL. So on the far left, we have the peanuts. We have the block of marble. We have the block of data. We have our raw input. In the middle, we have the factory, the SQL factory, the peanut factory, the chisel factory, the set of instructions that are going to be used to manipulate that raw input into the output, which is on the far right, which is the peanut butter, the statue of David, the list of the folks who were pregnant at Target. So let's start with the first bit of code. Select ID from table. The select statement. What does the select statement do? Well, the select statement is option C. This selects the columns that we want to see in the result output. We're selecting the ID column, so we look over at the table, and when we throw the ID column there on the right-hand side in our result output. Where does it come from? It comes from table. So E, the from statement, is a table that you want to look at. So select ID from table. We're looking at table, which is called table in this case, and we're selecting the ID, and out pops all of the IDs. What you'll notice about SQL is that it can be written on one line or more than one line. It actually doesn't matter. It is line agnostic. What you'll generally see is SQL is stacked on top of each other, like the first example here, the select ID from table, versus just written on one line. Also, tables and keywords are case insensitive. So SQL as a language is case insensitive and line agnostic. Select and from, these 2 keywords are required in all queries. So if you're writing a query, you're always going to be starting with select and from. You're always selecting some column from some table is where we start. All right, let's talk about the next result output. So here we're selecting ID and item name from table. And we're ordering by value DESC. What do we know about the select statement? Well, the select statement says, well, we're going to pull out the columns that we want to look at. So we're going to look at the ID and item name column. So we grab that from our table and then throw it over there into the result output. Where does it come from? It comes from table. And we're going to order by its value DESC. What does that mean? Order by value DESC. Well, the order by statement is option A. It orders our results either in ascending ASC or descending order. What's interesting here is that even though we're ordering by value, can we actually see the value on the right-hand side? Cheese tray is the most expensive item on the table, but we don't know its value. The reason why we don't is because we didn't select it. So just because you've ordered by something doesn't mean that you've selected it. And this is a common error that I see when a lot of folks are learning to order by. They'll say, I ordered it. Where is the column? Well, you've got to throw it in the select statement too. So if you order by something, generally a good indicator to throw it into the select statement as well, so you can see the column. Otherwise, it's in the background. So we're pushing that column forward. So whatever goes in the select statement is the columns that you're going to see. And then order by, we're going to order those rows and records by the value column with the highest value on the top and the lowest value on the bottom. All right, let's add the limit clause here. So all we've done is we still have select ID and item name and value from table, those three columns from the table. And we're still ordering by the value. So we're putting the highest value item on the top and then the lowest value items on the bottom. But now we have this new keyword called limit. So if I look on the far right, it looks like there's only 3 items. So what does the limit keyword do? The limit keyword returns a list, turns a specific number of rows back from the table. If you pair limit with order by, this is actually how you can rank data coming out of SQL. So the SQL code is really just show me the top 3 most expensive items in the table in English. But in SQL, it looks like that. So limit with order by allows you to rank records. All right, let's talk about the where clause now. In this example, we're selecting item name and value from table where category equals drink. And we're ordering by value DESC. So what's going on here? It looks like we're only wanting to see the records where category equals drink. So what does the where clause do? It's option G. It filters the rows in the table. Filters the rows. This is interesting. The select statement is concerned with the columns of the table, the vertical nature, and the where clause is concerned with the horizontal rows or records in the table. It filters them out. Now I want you to take a look here. I'm only filtering on category equals drink, you'll notice. But if we look at the result output, I don't see the category column. I just see item names and value. And I hope you're catching on here. Just because you filter on something, just because you order by something, doesn't mean you selected it. So generally, good rule of thumb is if you're filtering on something in the where clause, you're going to want to bring that into the select statement so you can use it. You can actually see what the column is. The where clause is case sensitive. So when we're filtering on rows and records, we need to consider case sensitivity. And we're going to go way more in depth about this keyword in our filtering class. All right, let's talk about the group by here. So on the far right side, it looks like we have a list of all the item categories in the table and then the total count of products within each category. If we look at the select statement, it says to count the item name as items and the category from table and group it by category. So what does the group by statement do? It's option F. Group by is used when you are aggregating data and then you want that aggregate broken down into specific dimensions. So when you've got a giant aggregate, like say the number 100, and then maybe you want that number 100 broken down into product categories. Like say clothing was $50 and toys were $50. So those are broken out by product category coming from 100. The group by disaggregates data into specific dimensions. And we're going to have a whole class on the group by. So with these keywords, I'm just giving you a 10,000 foot view of how they all work. Each class is going to be focused on a specific keyword and mastery of that keyword. So don't be expected to memorize this now. This will come with time. I just want you to be exposed to it here in the beginning. And I won't talk about the having clause. We'll save that for another class. So what are the next steps? You've gone through this intro lesson, the first class per se. It's actually class 0. So if you want to learn more about SQL, I suggest move on to class 1, where we're going to create an account in Mode Analytics, and we're going to cover select from, order by, and limit. We're going to do a code along. There's going to be homework after that class, and then the answers to the homework. All that information is accessible in the Google Drive links below. So make sure you click on those. If you have any questions, you could ping this thread here in the comment section. So add a comment below. I will respond to you. If I'm not responding there, send me an email. This is my personal email. I don't mind getting personal emails. Please send me an email if you have a question. And then after watching this series, reach out for access to a SQL assessment review session with me that you can book. But wait until you've gone through all the course content before creating that SQL assessment. So if you've already done that and you're just reviewing this video, that's in the link below to book a Calendly 90-minute session with me to review your SQL assessment. I really appreciate you folks tuning in. Thanks so much for supporting my channel. Thanks for watching my content. And get ready for class 1. Thank you.